Okay, some more examples where we're going to find the lowest common denominator. And you'll notice again, in this case, the denominators are not in factored form. So I need to write this in factored form first. And so the numerator is fine the way it is. In the denominator, if I write this in factored form, I have x plus 3 multiplied with x minus 1. And I'll do the same thing for the second RVE. X plus 5 multiplied with x minus 1. And again, when you're looking at the lowest common denominator, first check to see if there's anything that's already common between the two denominators, and then look for any factors that are missing in either one or both of the denominators. So I noticed that x minus 1 is common in both of the denominators, so that's already part of my lowest common denominator. And you'll notice that one of the factors that we have in the first denominator is x plus 3, and that doesn't exist in the second one. So that's one of the missing factors that I need to include. Similarly, in the second denominator, I have x plus 5, which is missing in the first denominator. So that's going to be part of our lowest common denominator as well. So in order to get these two denominators the same, the second one needs to be multiplied by x plus 3. And the first one needs to be multiplied by x plus 5. And then from here, it's just a matter of working out the numerator part and then collecting like terms essentially. Okay, the last one, again, we're going to look for a lowest common denominator. And you'll notice in this case, the denominators are all in factored form. They're all they're all being multiplied. So 4 times x, x times y, 3 times x squared. And so again, we're going to look at the numerical part first to find the lowest common denominator in terms of the numerical part, and then we're going to look at the variable part next. So in terms of the numerical part, I have a 4, a 1, and a 3, and so the lowest common denominator between the numerical parts is 12. In terms of the variable parts, we have an x in each one of the denominators. However, we have 2 x's in the denominator here, so we have x multiplied with x. And so we actually need 2 x's in each of the denominators just to fill in the missing factors that we have in the first and second denominator. Okay, we already have x squared here. We need to have an x squared in the first denominator and the second denominator as well. Also, we have a y in the second denominator that we do not have in the first or the last denominator, so we also need a factor of y in our lowest common denominator. So in order to make the first denominator 12x squared y, we need to multiply this by 3xy, same thing at the top. In order to make this 12x squared y, we need to multiply this by 12x, same thing at the top. And in order to make this 12x squared y, we need to multiply this by 4y. Okay, same thing at the top. And you'll notice that each of our denominators are now going to be 12x squared y, which means that's our lowest common denominator. Okay, let's look at a few examples where we're actually going to be simplifying the RVEs and then stating all the restrictions. And again, remember you need lowest common denominator in order to do this. And so in this case, because the denominator is already in factored form, we can already state all of our restrictions. And in this case, our restrictions are x and y both cannot be equal to 0. And then from here, we need to think about our lowest common denominator. And luckily, we just did this problem at the top, and our lowest common denominator was 12x squared y. So, because our lowest common denominator is 12x squared y, and I'm going to extend this line across, I'm going to write that down first. I'm going to write all my numerator terms over one set of brackets because I already know what the common denominator is going to be for the bottom. So I need to multiply the first set of brackets, or the first RVE, by 3xy in order for it to be the same as the denominator that I have here. And remember, whatever you do to the denominator, you have to do to the numerator as well. The second one I need to multiply by 12 times x. Same thing in the numerator as well. And the last one I need to multiply by 4y. And same thing in the numerator as well. And so I'll just rewrite this out. This is 7 multiplied with 3xy minus 5 multiplied with 12x. and then plus 2 multiplied with 4y. Okay, and just to simplify the numerator part, I have 21xy minus 60x plus 8y, and our restrictions are still the same. Okay, and you'll notice that there's no terms that I can combine together, so that's in simplified form. Okay, for our second example, again, we're going to simplify and state all restrictions. But in this case, you'll notice the first set of brackets the first denominator is already in factored form, but the second denominator is not. So that's the first thing I'm going to do, factor the second denominator. And I get 3 multiplied with t minus 4. And so you'll notice that in the first set of in the first denominator, I have a restriction such that t cannot equal 4. And you'll notice in the second denominator, it's the same restriction. So t cannot equal 4. And now in terms of my lowest common denominator, I'm just going to put brackets around the t minus 4. In terms of my lowest common denominator, notice that t minus 4 is common between the two denominators. And the only factor that's missing is a 3. So my lowest common denominator would actually be 3 multiplied with t minus 4. And so in order to get both of these denominators to look like 3 multiplied with t minus 4, the first set of brackets need to be the first RVE needs to be multiplied by 3, and the second RVE is actually happy the way it is. So what I end up with is 3 multiplied with t, which is 3t, and the second one is fine the way it is, which is minus 2t. Restriction is still the same. And so if I simplify the numerator, 3t minus 2t is just 1t. And everything else is exactly the same as it was before. Okay, for the next example, again, it's a similar idea. You need to write everything in factored form, then state all the restrictions, and then get a lowest common denominator from there, and then move on from there. And so if I factor the denominator in this case, I get 2x plus 1 multiplied with x plus 1. And then the second one's already in factored form. I'm going to put this in brackets, the denominator in brackets, just to show you a similarity between the first denominator and the second denominator. And what you'll notice is that now that it's in factored form, I can state the restrictions and then figure out the lowest common denominator from there. So in terms of the first set of brackets, my restriction is that x cannot equal negative a half. In terms of the second set of brackets, I have x cannot equal negative 1. So negative 1 is lower, negative a half is higher. So I'm writing it in that order. And the last set of brackets in the second denominator, you'll notice it has the same restriction as well. So again, for the lowest common denominator, you'll notice that 2x plus 1 is already common. And the only factor that's missing is a factor of x plus 1. And this factor of x plus 1 is missing from the second set of brackets, from the second RVE. So if I multiply the second RVE by x plus 1, you'll notice that the denominators are now the same. So what that means is the numerator part, the first one's fine the way it is, but the second one, I have positive 2 multiplied with x plus 1. And if I simplify this, I get 4 plus 2x plus 2 over 2x plus 1 x plus 1. And if I simplify this further, I get 2x plus 6 over 2x plus 1 multiplied with x plus 1, and my restrictions are still the same. You'll notice in this case I haven't been writing the restrictions in every step, and part of the reason for that is because the numerator and denominator haven't been able to cancel out, and so my restriction from the start to the end is still the same. Okay, whereas sometimes when you're looking at multiplying and dividing, the restrictions may change. That's why it's important to write it in each step there. But when you're adding and subtracting, typically the restrictions don't change. And so whatever restriction you wrote at the beginning is typically the same as what you write at the end. Okay, just one quick little thing. The numerator in this case is factorable, but you only want to factor it if you think it's worth it to factor it. And in this case, it's not, because factoring this won't actually cancel out anything in the denominator, so you're fine to leave it the way it is. Okay, our last example, we're going to simplify the RVE and state all restrictions again. So first step is to factor and then state all restrictions. So we have a over, we have a difference of squares in this case, so a minus 5 and a plus 5 minus 2 times, again factor this, you get a minus 5, a minus 4. And so in terms of our restrictions, we're looking at the variable a, and you'll notice that a cannot be equal to positive 5, negative 4, positive 5, sorry, I apologize, positive 5, negative 5, positive 5, and positive 4. So in order from lowest to highest, I know that a cannot equal plus or minus 5 and positive 4. And again, you'll notice that there's already a common factor between the two denominators, and that common factor is a minus 5. And you'll notice that each of the other denominators are missing one of the factors. So this denominator is missing a factor of a minus 4, and the second denominator is missing a factor of a plus 5. So in terms of my lowest common denominator, I have a minus 5, which is common, a plus 5, which is common in one of them but not in the other yet, and then a minus 4, which is common in one of them but not the other one yet as well. Okay? And so what that means is, I guess I can rewrite my restrictions. A cannot equal plus or minus 5 and 4. What this means is the first RVE needs to be multiplied by a minus 4 in the numerator and denominator. And the second RVE needs to be multiplied by a plus 5 in the numerator and denominator as well. And so I already have a common denominator. You can see that between all the factors in the denominator here. And so now it's just a matter of simplifying the numerator part. And I'm just going to rewrite it because sometimes it's easier to just see it written out before you expand and simplify. And so now I can expand and simplify the numerator part. I get a squared minus 4a minus 2a minus 10. And then I have all my factors just like I did before. And then if I simplify, I get a squared minus 6a minus 10 all over a minus 5, a plus 5, and a minus 4. And in the last step, always remember to write your restrictions. A cannot equal plus or minus 5 and 4. And that's it.